Okay, let's do another problem from chapter 19. Sodium has an atomic number of 11 and an atomic weight of approximately 23. How many neutrons would you expect to find in the nucleus of the most common isotope of sodium? Okay, so let's figure some things out here. The atomic weight remember that is like it's close to the number of neutrons plus the number of protons. Okay, it's about equal to those. The atomic number is the number of protons. Okay, so we're just going to say we have, if we look here, the atomic number is 11, so the number of protons is 11. Right? The atomic weight is 23. Right? So hopefully you're seeing that 23, we can make an equation now. 23, the atomic weight, is equal to the number of neutrons plus the number of protons. I said the number of protons is 11. So hey, we can just simply subtract and we can get the number of neutrons. So yeah, I'll leave that at that. Let's try another one. Strontium-90 is radioactive isotope of strontium, which has an atomic number of 38. How many protons and how many neutrons are present in the nucleus of this isotope? So this is a mass number, that's what your book calls it. That's close to the atomic weight. They're very similar. The atomic weight is like the average of the mass numbers of different isotopes of an element. So when this one was saying, okay, how many would you find in the most common isotope? Well, the most common isotope is 23, since the average of the mass numbers is 23. So the mass number of sodium, the most common type, is 23 because the average of the mass numbers is 23. So we come to here, we don't care about atomic weight now. We're told exactly what it is. The mass number is 90. Hopefully I didn't confuse you with that. So the mass number is equal to 90. That is equal to the number of neutrons plus the number of protons. Back here, I was saying it's about, I should put squiggly lines. That's because the atomic weight was close to the actual mass number. So I should have just said, okay, what's the mass number of the most common isotope? Well, that would be 23. Okay. So let's go back to this. The mass number is 90. That's the number of neutrons plus protons. We have an atomic number of 38. Okay, so how many neutrons? This is similar to the problem we just had. We're just going to take the 38, plug it into here for the number of protons, because the atomic number is the number of protons. So you're going to have 90 is equal to the number of neutrons, neutral charge. Okay, you're going to have that. Do your algebra, solve for the number of neutrons, and you'll have your answer.